Hey everybody, and welcome to the 12.5 videos, which is about mixed practice, graphing conics, and writing equations. And there's going to be multiple parts. Originally, I was thinking that there might be 2 parts to the video, but I'm actually thinking that I would like to do 3 videos here, all based on type of question. So video 1 will be numbers 1 to 4. Video 2 will be numbers 5 to 8. And video 3 will be numbers 9 to 11. So they may not all be 15 minutes, but it's by type instead, which I think might be useful to you. So if we get started, type 1 is when you're given a picture and you need to find the equation. And so first, let's identify what we have. In example 1, we have a parabola. And it looks like it's a parabola that is what we expect in a parabola, that is a function. And when it is a function and it's pointing downwards, it's going to be something that's x squared. And so my general formula is going to be something like this: x minus h squared, and the x is squared because, again, it's a parabola of what we expect, equals 4p times y minus k. So in order to get this right, I need to figure out what h and k are, and I need to figure out what the p value is. So h and k are not too bad, because the problem gives me that the vertex is 2, 3, so I have h and k right there. The p value, remember, represents the distance from the vertex to the focus, or the directrix. You could even say and there. So if I take a look at this vertex, my directrix is right behind there. So it looks like this distance here is 2. Which means my p-value is 2, which means this is really 8. So I can already figure out my equation. It would be x minus 2 squared equals 4 times 2 technically, times y minus 3. So even more simplified, my answer would be x minus 2 squared equals 8. I'm leaving room there for a reason, times y minus 3. The last thing I need to remember is, because my parabola is facing downwards, we generally do not put the negative in front here. We put it towards the p-value because everything depends on the p, or the focal length there. So I would put a negative right there because the parabola is upside down. So this would be my answer for example 1. Example 2, circle. The equation of any circle is x minus h squared plus y minus k squared equals the radius squared. So what I need to find this equation is I need to find the center and I need to find the radius. So this one actually is not too bad either. I know that the center is -1, -3, so I already know my h and k values from that. My radius, I can just count in any direction that I like. If I want to count this way, it looks like my radius is 1, 2, 3, 4 units. If I even draw the radius upwards, 1, 2, 3, 4 units. So my radius is 4. So this one's actually pretty quick as well. I would have x minus -1 squared plus y minus -3 squared equals 4 squared, or even better, x plus 1 squared plus y plus 3 quantity squared equals 16. So this is my answer for number 2. Number 3 is an ellipse. And specifically, this is an ellipse that looks a little bit longer top to bottom, which means this is a vertical ellipse. So if I'm thinking about a general equation for a vertical ellipse, what matters, again, the a value is larger for the y this time. So if I wrote the general equation for a ellipse, we'd have x minus h squared over. Now, because this is vertical, the a would not go here, so this would be b squared plus y minus k squared over a squared, because a goes with the larger axis, the major axis, equals 1. So again, I need to find my a, I need to find my b, and I need to find my center. So I'm going to draw what I think the major and minor axes are. So my major axis, well actually first my center looks like it's the point 2, -3. So I'm going to write a little note up here. My center looks like 2, -3. So I know my h and k already, which is again great. My A represents the length of my major axis. So my whole axis is 1, 2, 3, 4, 5, 6, 7, 8 units, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's 10 units. So if this distance here is 10 units, that means that my A value must be 5 because A is defined from the center to the major vertice. My minor axis here is 1, 2, 3, 4, 5, 6 units. So this is 6 units long, which means that my B value must be 3 because it's defined from the center to the minor vertice. And so I actually have everything I need here. I have my center, so I have x minus 2 squared over b squared, or the smaller axis squared, so that would be 9, plus y plus 3 squared, because we have minus a -3, all over a squared, or 25, equals 1. So this would be my answer for my vertically based ellipse in number 3. Last but not least for this video of this type from a graph to an equation is example 4, which is going to be a hyperbola. And this one also seems to be vertically based, like the ellipse, because the pieces are facing up and down. So I know that my y value has to be positive or in front. So I'm going to make a little note here. Y would have to be positive, and that determines my a value. And I'm also going to write a little note that this is, again, a vertically based hyperbola. And so if I want to write a general equation there, the y minus k squared would have to go in the front. So that would have the a squared on it, minus x minus h squared, b squared equals 1. So this time the center isn't as apparent, but we can find it because remember that the center is directly in the middle of the vertices and directly in the middle of the foci. So if I look from vertice to vertice, I have 1, 2, 3, 4, 5, 6 units. So my center must be in the middle. 1, 2, 3 it looks like. 1, 2, 3. I also could check from the foci to see if it's the same distance. 1, 2, 3, 4. 1, 2, 3, 4. Correct. So my center is at -3 up 1. And from this picture, I can also find my A and C values because the distance from the center to a vertice is defined as A. So A is 1, 2, 3 units here, and it's 1, 2, 3 units here. So I know that all my A values, no matter what direction, is 3. If I would like to find my C value, that is defined from my center to my focus. And that is 1, 2, 3, 4 units in either direction. So I know that A is 3, and I know that C is 4. So while we're at it, because I know I need the B anyway for my equation, let's find it. C squared, remember the equation has a negative in it, so it's A squared plus B squared, to use the Pythagorean theorem. C squared would be 16. A squared would be 9 plus B squared. So B squared would equal 7. And it's true that B would be the square root of 7, but I don't really care because all I need is B squared for my complete equation. So my final answer here would be y minus, so k is 1, squared over A squared, which is 9, minus x minus a -3, would really be plus 3 squared, over B squared, which is 7, equals 1. So this would be the equation for my hyperbola on number 4. Feel free to pause and rewatch any of these examples, but this is the first type of review or mixed practice in section 12.5. Numbers 5 to 8 will be on the next video. Thank you.